Thank you all for coming out, sticking around. This is a talk on cloud red teaming. Specifically, we're going to talk a little bit about FIDO2, WebAuthn, and how we can use serverless services to, kind of defeat some of those security controls. I'm Bryce Kunz. So my background is I used to run incident response and hunt for Homeland Security's unclassified SOC. So about 500,000 endpoints worldwide, where we were really focused on finding various APT groups that tried to breach the network and strategically removing them from the network. My real passion is the offensive side of the house, so I've been into the offensive stuff since I was pretty young, and so made my way up to NSA and ended up being a technical director up there over a red team type unit, responsible for collecting more data about APTs. Relocated to Utah, built a red team for Adobe, and did that for a number of years. And then I left and started Stage 2 Security, where we really focused on pen testing services, and that's now been rebranded as Ultraviolet. So if you've heard of Stage 2 or Ultraviolet, that's where I kind of spend a lot of my time these days. Ultraviolet, that's really a combination of 4 different companies, and we're merging together the people and technology stacks. So mostly on the defensive side, and then on the offensive side, we're still, chugging away there. And really, the reason we call it Ultraviolet is because it's the combination of the red and the blue coming together to get the purple, right? So if you're interested in any of that, feel free to stop by our booth. We have UV mini badges that you can solder together and all that, which are pretty cool. All right, I also run the B-Sides conferences in Utah. There's a new one that we're going to do in St. George later this year on Saturday, December 9th. So check out the website. Tickets are just $20, and it's on the campus there at Utah Tech. In addition, we're going to do B-Sides Salt Lake City again, and that's going to be April 12th. There's not a lot of information on the website yet, but feel free to join the Discord. Appreciate everybody's support of these events. They really are kind of a platform for the community to get out there, and we wouldn't really have anything if it wasn't for all of you contributing. Cool, and those are nonprofit, right? So we have a nonprofit and all that. All right, cool. So I'm gonna just dive into the meat of it. I'm gonna try to go a better pace than prior years. So hopefully, that's helpful. So just talking about cloud service providers, the 3 most common ones are AWS, Azure, and GCP. The bulk of our clients are on one of those 3. There's a lot of other cloud service providers out there these days. So, I'm sure you're probably using something else besides this in addition. And I just tried to kind of like map back different services, how they actually relate to the service. There's a lot of like marketing information out there from the cloud service providers. So sometimes it's helpful just to jump to the technical documentation to see what the services actually do. But this might help you if you're looking for kind of a quick translation. Another thing I just want to highlight out is there's kind of a difference between the cloud service providers like GCP and then kind of the office productivity workspaces, the Google workspace, right? If you've ever done Google Docs, things like that, those are kind of 2 different offerings. And then the same on the Microsoft side, you got Microsoft 365, and you've got Microsoft Azure, and there's some interconnections here, but for the most part, I like to call out that these are kind of 2 separate things to help students kind of digest it. Oh yeah, I teach a course at Black Hat that's all about red teaming against cloud targets. It's like focuses on going in depth in a lot of this content. So, okay, at a high level, when trying to train somebody up on offensive methodologies, I usually like to break it down into 3 steps. So the first is just prepare. Second is, exploit or gain access. And the third is kind of prosper. So in the prepare phase, you have all your recon and discovery that you've probably heard at talks over the years. But the biggest thing here is you want to plan, right? You want to set your goals. You want to come up with a strategy to meet those goals. And you want to make sure that you and the client are on the same page, right? Part of this is really, making it a win-win for both your team and as well as the clients. And a lot of times the clients will kind of know, hey, we have these initiatives coming up next year. We'd really like to see more findings in these type of areas. Feedback like that is really helpful because, all engagements are limited in time for the most part. And so you've got to kind of make some tough choices on where you're spending your time. And, we always want to kind of spend our time on the things that are most impactful for the clients. Okay, so then, there's gaining access, right? So that's exploit. And the biggest thing here that is totally overlooked for the most part is actually testing. For the most part, you want to kind of replicate the target environment inside your own, your own cloud account, right? Your own AWS account, or your own ESXi server. So you can test, and when things go wrong, you can kind of replicate that in the lab rather than just kind of blindly throwing exploits across the internet or whatever. So yeah, so always test, 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 test. And then the last, prosper, right? These are all the post-exploitation favorites about escalating your privileges as well as persisting or pivoting. So when it comes to cloud, I have a kind of more detailed methodology. So I call this the Nimbus Assault 3D grid, and you'll kind of see why as I walk through these slides. But basically, we're going to start off with recon. That's pretty normal. And then we can either attempt to get client-side access to a laptop, like a Mac laptop or a Windows laptop, or we can try to get server-side access, find a bug in the web applications. And then either way, we're really just trying to get credentials to the cloud service provider. And then once we get the credentials to the cloud service providers, we can leverage the credentials to talk to the control plane APIs. That's this left side here where it says control plane. Or we can leverage the credentials to get more traditional C2 inside a compute type service, like Amazon's EC2 service, or something more hipster like Lambda or something like that. So yeah, sorry. Yeah, so either way, you're going to leverage the creds to try to further your access. Security architects, they plan out how the world should be. So it's a very mature game, and they have all these great plans, especially cloud security architects, and they're awesome. I've worked with quite a few over the years. But then there's kind of the engineers that actually implement it, right? And the implementation may vary from what the architects originally intended. And then then there's the red teamers, right? And they're just there looking at everybody's moves and trying to rip it apart. And really why I say this is kind of like a 3D model is because if you get access to the control plane and you kind of get stuck on your privesc, a privesc method is kind of to hop back down to the data plane, move around on different systems, which might have different credentials, and then kind of hop back up to the control plane. And then oftentimes your end goal is going to be in the data plane. Like the data plane is going to have your data, and you probably want to exfil that. So to show impact to the organization, getting an administrator to the control plane, that's like the equivalent of getting domain admin. That's cool, but what really freaks a client out? When you get access to the CEO's email, right? So you want to get access to impactful data. Okay, so do recon, maybe find a bug in a web app to get server-side access, collect creds. In kind of a more detailed view, when we're looking at external resources, maybe there's a web app running on an EC2 instance, maybe there's a role assigned to that, and that role will enable that instance to have certain credentials, and typically those are going to be stored in the metadata service. So that's a pretty traditional scenario on how to get access or get some foothold into the target cloud account. Another method that's less talked about is there are certain edge cases where you can kind of skip over and go directly to collect creds. A lot of the cloud providers have services to allow you to globally share resources. And there are projects out there where they try to mine these different resources. So for example, if you take an image of your VM and then you globally share that and it has credentials in it, like obviously somebody else could probably use your AMI to create an instance and then extract the creds. So yeah, so that's kind of a way you can kind of shortcut that process. The issue with this is it's not very target specific, right? It's hard to say like, hey, I'm doing a pen test for this company. Now I'm going to mine all the globally shared resources for that. That's tough. But you can find somebody's credentials out there. That's reasonable. Okay, on the client side access, this is where we're trying to send a malicious document to the user to get them to run it. We're trying to steal their cookies. And we're trying to get to a user that has access to the cloud account, which has some level of permissions like the admin. And once we get it to, let's say we get on an SRE's box and they have admin, we can ride through that to affect or modify the resources like EC2 instances. And maybe those EC2 instances also have different roles assigned to them, which have different policies attached to them, which may give us more privileges inside the AWS account. So it's kind of another just showing how you can bounce back and forth between the control plane and the data plane. There's numerous vulnerabilities that come out every year to get you client-side access. There's some new ones this year that revolve around Microsoft Excel documents and things like that. But yeah, this is just a constant game of cat and mouse, right? But browser cookies or stealing of SSO sessions, these have gotten really popular in recent years. There's kind of a cool website cool project called Cookie Crimes, where they kind of lay out all the cookies for each cloud service provider that you want to collect if you get on an endpoint or you are able to get inside man-in-the-middle someone's browser connection. So this is pretty good. It lists them out for GCP, Azure, AWS, all that. So there's also another technique here. Check out the references for more details. References at the bottom of the slide. Slides will get pushed to my speaker deck account, and I'll put a link on Twitter and LinkedIn. So, okay, so how do the adversary-in-the-middle systems work? You've probably heard a lot about this in the last year, but basically, you're going to trick the user into making a connection to their SSO or their secure login system, and you're going to have a proxy in the middle, right? Your evil proxy. So maybe you send a link or in an email or some other type of communication. The user clicks it. They kind of go to your evil proxy. Your evil proxy forwards it to the system that's going to log you in, and then it kind of forwards the request back. And once you successfully authenticate, then the attacker can kind of ride on that session data to authenticate to the SSO solution, and then maybe potentially access the CSP or SaaS product that the user had access to. So, there's been a lot of work on endpoint protection over the years, and looking at the MITRE attack framework and trying to find actors on the boxes. And the reason that a lot of actors are using this, in my opinion, is because it works, and EDRs largely ignore what's going on in the browser these days. So they're more focused on what's going on in the host. These are some common projects out there to do an evil man-in-the-middle attack. And then, one of the most popular software out there for sending phishing emails is GoPhish. And then there is a project out there that tries to combine these two together into one coherent system. Okay, so one thing that I just want to highlight here is when the attacker sends the link isn't actually going to go to the right domain name, right? They're going to try to trick the user into going to the attacker-controlled domain name. And that domain name will probably have valid certs, like from Let's Encrypt or another service. So, it'll look signed and good to the user, but if they look really close at the domain name, it's going to be slightly different. So there's a lot of newer technologies out there which are going to verify that not only the user is securely logging in, but they're securely logging into the correct domain name, right? And so if you have like a FIDO2, like a hardware token, like a YubiKey, and you enable WebAuthn, it's going to do that domain name verification, and it's going to prevent the attacker from being successful. There are other solutions out there that would help you defend against these attacks, and some of those are newer. But basically they come down to they're going to verify the domain name in addition to just kind of the certs and things like that. So yeah, these are really effective defenses. I also know there's a FIDO2 implementation for iPhones and things like that. Yeah, this is kind of a setup that I've seen that's highly effective at stopping these attacks. So I was trying to think of ways that you could still be successful in an engagement, even when they have WebAuthn and FIDO2. One that I think is kind of underutilized now is malicious browser extensions. There is a project out there that is called Curse Chrome. That's kind of a malicious browser extension. So if you can get someone to install a Chrome extension and it's got some of the Curse Chrome code inside of it, then that establishes a C2 attack channel with the attackers and enables the attackers to kind of write any sessions that are currently in your browser. So this is a cool project. Check it out. I don't really know anything about building browser extensions, just to be honest, earlier this year. So I turned to my trusty friend, ChatGPT, and said, hey, will you just make me a browser extension? And it was super easy, man. It just made me a browser extension, right? So super easy to get going. And then a little bit harder, you had to integrate the Curse Chrome code into the code base, but not that hard. And then you'd have to trick the user into installing the extension. So definitely an area where I think we will see more attackers pushing to as more defenses get ramped up. There is, if you're using Chrome, you can implement enterprise policies and whitelist specific Chrome extensions. There's also software solutions to do that as well. So maybe something you want to think about if you want to kind of get one step ahead of where attackers are probably going to move in the future. There's a lot of ways in the cloud that you can kind of leverage the reputation of the cloud service providers by like hosting files in Azure Blob Storage or S3 buckets, and then kind of linking out to that as part of phishing attacks. That's not really anything new. Consent grant attacks, if you're not aware of these have been going on for some time. Microsoft's pretty aware of them, and they've taken steps to try to make it harder for attackers to pull this off. But basically, you try to trick a user into granting your application that's hosted in Azure AD into having certain level of accesses. You need to kind of be like a trust in Microsoft's trusted companies groups in order to get full permissions these days, which is really kind of curtailed the amount of attackers using this. But you can build you can do this attack and collect email addresses still without really having a signed application. So that's a potential attack vector if you're just trying to collect email addresses. Maybe good if you're Zoom info. Anyways, I probably shouldn't have said that. Okay, so next section is social stack, set smother. Okay, so Scott Piper had a really interesting blog article, Utah-based cloud security guy, great guy. So he talks about lesser known techniques for attacking AWS environments. So that's where this idea kind of came from and some of the research behind it. Okay, so this is the example. We have the target's AWS account, and you have an admin, and he basically has full permissions to it. That may or may not be realistic in your specific target environment, but for a lot of companies, this is definitely the way they operate. And now we have an attacker's AWS account that they own, and just for simplicity's sake, typically you'll have a globally unique 12-digit number associated with your AWS account. So I've just shortened those down to 5 digits, for example, but In real life, that would be 12 digits long. So the target account is 90210, and the attacker's account is 31337, just for demonstration purposes. Okay, so I was trying to think, is there a way we can leverage this to kind of bypass the FIDO2 with WebAuthn? And there is a feature here where you can kind of quickly launch a stack. So basically, you could send someone a link. They click the link. It'll take them to one page. And at the bottom of the page, there'll be a button that says Launch Stack. So I thought, that's interesting. Maybe we can get, the victim to launch a malicious stack and, get admin access inside their environment. The user would already be authenticated via their browser, so WebAuthn and FIDO2 wouldn't be applicable. We would just kind of ride their existing session. So couple caveats. The CloudFormation template that the victim's going to run needs to be stored in an S3 bucket. So in my attacker account, I'm going to create an S3 bucket. I'm going to put the malicious CloudFormation template in there. That's that cftemplate.yaml file. And I'm going to make it, publicly readable so anybody can pull the file on the internet. And then I'm going to send them the link, and it's going to link to that object in the attacker's bucket. This is what it looks like. So they have to click the button at the bottom that says, I acknowledge, and then click Create Stack. So you probably want to have some type of pretext that's going to convince the user to do this, like, hey, we know you're using this cloud service, and there's an update needs to get implemented, right? But you can come up with your own pretext. Okay, and so when the CloudFormation template gets deployed, right, the stack is going to get created, and in that stack, this template's going to create a role, and it's going to attach an admin policy to the role. And that policy is just going to say that a role in the attacker's account can basically have admin access into the target's account, and the policy attached to that is going to help that happen. So the attacker can kind of ride these roles and assume into the roles. A role is like a service account in AWS, if you're not acquainted with that, to get admin in the target account. So the one issue with this is that the attacker at this point, even when the admin deploys the malicious CloudFormation template, they don't really have a solid way to know what the victim's AWS account ID number is, the 90210 number, or in real life, a 12-digit number. And they're going to need that information to kind of ride back this role connection that we've established. So there is a feature when you're deploying a CloudFormation stack where you can define a custom resource, and that custom resource can actually be like a Lambda function, and that Lambda function can actually execute as part of the deployment process. So I wrote an AWS serverless application using the SAM framework, which we'll talk more about in the future slides, and that will create an API gateway as well as a Lambda function, which is just going to collect the 90210 target's account ID number and store it in an attacker-owned S3 bucket. So just try to automate the setup a little bit. Okay, and then we add in the custom resource to the CloudFormation template. So when it gets deployed by the victim, it creates the role with the policy. It kicks off a Lambda function. That Lambda function sends the data back to our API gateway in the attacker's account, and then the Lambda function on the attacker side processes it and stores it into the bucket. So this is a setup, and will successfully work. Granted, you trick the admin into actually running it. The code for this is all on my GitHub. So if you want to check it out, yeah, it's all there. So this is really just the first version. It has quite a few areas that could be better. First off, the CloudFormation template that we get the admin to click assumes that the admin has the ability to kind of modify resources in IAM. And sometimes in certain environments, there'll be SREs that have basically administrator access of the virtual machines or EC2 instances, And then there'll be other people who kind of have the admin access to AiTM, and you have to like submit JIRA tickets to kind of work between the two teams. So that might be an issue, right? There's like a bunch of things, like the CloudFormation template. I didn't really obfuscate the Python code, so it's pretty obvious where the API gateway is located, that it's sending back the data. There's a number of ways you could overcome that. And then, the last one that I'm just going to talk about for a minute is, the phish, which is the first thing they see and probably the thing that gets the most scrutiny initially. I mean, it has a link to the attacker-controlled bucket, which is a globally unique name, right? All S3 buckets kind of have a globally unique name. So, I mean, it's really trivial for the defenders to just send like a takedown notice and kind of get the attacker's AWS account, canceled, right? Just kind of working on these one at a time. I did some research earlier this year and kind of talked about V2, I believe in B-Sides Austin. So this is kind of the areas where we get the most scrutiny, right? So we get a lot of scrutiny on the initial phish, like the email or message. We get scrutiny on the template, and we get scrutiny kind of on the S3 bucket and the object there. All right, so here's my ideas. I'm trying to hide the attacker's S3 bucket because I don't want to get takedown, right? I don't want to get takedown notices, right, as the attacker. So here's my ideas. First idea, set up a redirector that just forwards to an S3 bucket, right? And that thing could just be burnable. Second idea, very similar, is kind of put a CDN in front of it to try to obfuscate it. And third idea is just find somebody else's bucket and use their bucket. That way, when the takedown notice comes, it's not your problem. All right, so when you send them the link and they click the link, it's going to link out. It'll show it here. It'll also show it in kind of the URL as part of the get parameter, the attacker's bucket. So I was just kind of looking at it, and there's some other talks out there that talked about some of this stuff, but this is kind of what the valid URL would look like to the attacker's malicious CloudFormation template. We're trying to focus on that template and the CloudFormation service. Okay, so if we change the name of the object or file to something that's invalid, we obviously get an error. It's not able to pull the CloudFormation template, and it tells us. This is good because we can see, like, hey, we got pretty verbose error messaging with the CloudFormation service telling us exactly, like, this is not going to work, right? Okay, so the next thing is maybe we can try a different location. If the URL does not contain the string S3 or AmazonAWS.com, we're just going to get this invalid template URL message. So this is kind of a bummer because this kind of is going to stop a lot of the redirector type ideas. I did try to set up like my own custom domain names which contain these same strings, but I wasn't able to like figure out a way to bypass their validation checks here. So the one interesting thing that is of note is that the protocol or schema at the beginning, it completely ignores. You could put any protocol you want at the beginning, and this is still going to deploy. So if you put, my name, Bryce, that's going to work. Another thing that's of interest is you can add a port in, and it's just going to ignore it. So you can say, like, hey, this is on port 2222, and it doesn't actually go to 2222. It still goes to 443. So, you could kind of combine some of those factors to kind of confuse some of the defenders. Maybe they try to connect to a server on an invalid port, and they're unable to get the malicious CloudFormation template. It's not foolproof. Like, obviously, you guys know now that, yeah. But, it's a additional step to kind of confuse defenders. All right, so the redirector thing, after spending several hours on it, I just kind of said, hey, that's not going to work. So let's try the CDN thing, right? So I just tried to use Amazon's CloudFront CDN, but once again, I ran into kind of the validation of the URL. like cloudfront.net is not like an acceptable replacement for Amazon AWS.com. So this also does not work. All right, so that kind of leaves me with the last option. Let's just host in somebody else's bucket, right? So just to kind of recall back, we got the email, it's got the link. The link is going to deploy the CloudFormation template, and then we're trying not to host the object in our S3 bucket. Okay, so I did recall back a while ago, there was an actor, these mage cart actors, right? And what they did is they enumerated a bunch of S3 buckets, object storage buckets, and they just found JavaScript files. And then they found JavaScript files which were world writable. And then they just tacked their malicious payload at the bottom of the JavaScript files. And they were able to get on some really popular websites, right, by just looking for these misconfigurations in Amazon S3 service. But that was in 2019. That was quite a while ago. Would anybody realistically still have objects in an S3 bucket misconfigured publicly in 2023? What's the level of effort to pull this off? Is this something that I can do in a weekend, or is this something where you need like a whole team of people working on it? So those type of things. Okay, so thought I'd kind of dig into this more. And I really like Amazon's serverless application models. It's kind of a template that is going to get translated into a CloudFormation template and launched by the CloudFormation service. You might ask, why am I going to do that? It's because you can write SAM templates that are much shorter, and that will expand out to much bigger CloudFormation templates. And here's kind of an example of like a basic serverless app where you're hosting some static content in an S3 bucket. When some dynamic thing happens on a form, that goes to an Amazon API gateway. The API gateway sends the data to an AWS Lambda function, and maybe it stores some of that in a database like DynamoDB. This is kind of talking a little bit about some of the shortcuts here. So they have these new resource types inside of the SAM templating standard, which are going to kind of expand out and help reduce the size of your templates that you're writing. So things that are like really easy to do in SAM are like set up an SQS queue, set up a Lambda function, set up an API gateway, database, kind of all the common stuff you need to create a serverless app. All right, so we use SAM on our IDE. That's going to translate it into a CloudFormation template and push it to the CloudFormation service. In this example here, this is really simple. It's just going to create an API gateway, a Lambda function, and an S3 bucket. And we're going to launch some Python code inside the Lambda function. Okay, this is kind of what a SAM template looks like. I'm going to use Cloud Watch events to trigger this Lambda function every so many seconds. I'm going to attach a policy to the Lambda function that lets it write to the S3 bucket. And then I'm going to set the max time of the Lambda function to 15 minutes, because that's the max time you can run a Lambda function in AWS. Okay, and then I just generate a random bucket name using the standards defined by Amazon's AWS and by Amazon's documentation. And then I ensure it meets their requirements before I try to connect to it. And then I just try to connect to like 33 bucket names randomly, and I look at kind of the HTTP response codes to see if the buckets exist or not. And then I just write the results in an S3 bucket. So that's kind of all that this SAM app does, and a copy of it's in the GitHub if you're interested. So I just let that run for a while and collect a bunch of information about valid S3 buckets. Like obviously, there's other ways that you can find valid globally unique S3 bucket names, which would probably be even better than this. But this is like really easy to hack out real fast. So I really like the Cloud9 IDE. It's a browser-based IDE that Amazon acquired. So it makes it really easy to build SAM apps inside of it. Or if I'm on kind of doing something bigger, I typically use PyCharm with kind of the SAM extension in it, which makes it real easy to push out the SAM apps as well. Okay, so then I just wrote some scripts to process the valid S3 buckets. I wrote one that would download the objects with the valid bucket names. I would validate that the buckets exist and that we have some level of access to it, like it's a public bucket, and then a third script just to kind of see if I can put a file in the bucket, and then it just tries to remove the file from the bucket right after it puts it. So the results, in about 5 days of just letting the system run on its own, I found about 10 buckets, which were all world writable, right? So, and that's with just kind of this crude implementation of it. So yeah, the conclusion, there's definitely still buckets out there that are world writable that an attacker can easily find. It took me a few hours to code this up, and I just let it run for a couple days. So it's not really that cost intensive. And anybody, with some basic Python 3 skills, maybe some ChatGPT access, right, should be able to hack this out pretty quick. So I did release that code in the bucket earlier this year. So that kind of crosses that one off the list. I'm going to continue to work on this research area a little bit more. Probably in early next year. So look for future talks at the B-Sides conferences. So once again, we got a B-Sides coming up in St. George, as well as one in Salt Lake City in April. And I have a couple more minutes, so I just wanted to talk a little bit about how you can get better at cloud hacking. This is a question that I frequently get asked by people that are kind of getting into cybersecurity in the industry. And I think the best way to learn it is to get a hands-on lab type going, because then you can start to solidify a lot of the concepts, right? And I'm a big believer in kind of like an iterative approach to learning, right? Where you do some research, then you try some hands-on things, you figure out, okay, that worked, that didn't work, and then okay, I need to research these things more, and then you try some more hands-on things, and you just keep looping around, right, till you become an expert at it. So that's, kind of similar to OODA loop, but, a little different. So there's a lot of vulnerable lab environments out there that you can deploy. This is a list of some of the ones that I think are, worth checking out. Specifically, if you want to learn more about permissions and misconfiguration of permissions in AWS, I really like this IAM vulnerable project. So it's going to establish a bunch of different policies and roles and users, and then there's going to be privileged escalation paths. And you're going to be able to walk through that and kind of solidify your concepts of how an attacker might be able to priv-esc once they get that initial set of creds in the environment. So that's kind of that, control plane, kind of like the left side of that, Nimbus attack grid matrix. On the right side of the attack grid matrix, where you're kind of talking more about the data plane, CloudGo is good. It's going to create some resources via Terraform, and it's going to have vulnerable resources or vulnerable compute. And those are going to have roles assigned to them, which are like service accounts in AWS, which will have policies and that will enable them to have access. So there's less scenarios here, but it's going to really help you on that kind of right side of the Nimbus attack grid. I haven't played with Cloud Foxable, but I thought it was interesting, so I put it here in the slides. Looks kind of cool. On the Azure side, if you're more interested in Azure, SAD Cloud kind of focuses on resource exploitation, also deployable via Terraform, so that's a good one. If you're more looking at Azure Active Directory, or Entrada ID as it's known now, Bad Azure is a pretty good project. It's got kind of a PowerShell script that's going to create users and permissions around them, and there's going to be some privilege escalation paths there. So that's a good way to get up to speed on that one. There's also Azure Go, which is more focused on the resource exploitation angles. It's kind of an interest. On GCP, there's not a lot right now. There is GCP Goat, but it's really, really basic. So this is probably an area where the community could build more cool stuff. Here's some other kind of capture the flag type things that could help you out. Lastly, I'll just cover a couple more. I've got a lot of guides here. I'll post up the slides. So these should help you when you're going through those lab environments if you're getting stuck. The payload, all the things, GitHub repo is pretty decent. Yeah, there's a lot of decent references here. One thing that's really of use is kind of these tools that are going to help you visualize the permissions inside the cloud providers. Road tools, AWS PX, Storm Spotter, those are some of the ones that I've used in the past and had good success with. But there's a lot out there in this space. If you just want to learn more about cloud, like how it works and maybe some of the security aspects, like, hey, I'm a SRE or I'm a sysadmin, or and I want to level up, or if you just want to get some certs about cloud provider certs, I really like A Cloud Guru. They were recently purchased by Pluralsight, but they have really in-depth lectures on all the cloud services, and there you have all these pathways to help you get certified. So even if you're not going to be like red teaming, but you just want to know more about cloud security, this is a good place to start. Cloud Security Docs has some good information. I really like Cloud Seclist. They come out with a weekly, sorry if I went too fast, but I really like Seclist. They have a weekly newsletter that talks about all the latest tools and techniques and blog write-ups. So that's a really cool thing to subscribe to. Or if you don't like emails, you can just go look at the archive and read the past issues on the website. asecure.cloud has a lot of examples of how you can secure your environments, especially on the AWS side. So that can be a good resource. And then the Cloud Security Alliance, they do have a guide on pen testing for the cloud. It's not super in-depth, but hopefully someday it gets an update and becomes more thorough. Last but not least, there's this website, infocon.org. If you haven't seen it, definitely check it out. Basically, they have torrent files for all the conference videos they can find. So you can quickly download all the DEF CON videos, right? And if you're on an airplane flight with no internet, you can kind of watch them, right? So this is a really great resource. All right, I know it's getting late in the day, and this is the last talk, so I'm going to wrap it up. I got some stickers up here. I got maybe a couple UV mini badges if anyone wants one. There's more down at the booth. This is my Twitter handle, my LinkedIn, email, and I'll post up the slide deck later today. And if you want to check out the code, it's on there. Any questions? If there's questions, just come to the front. Yeah, go for it. Is there an Azure, what'd you say?
There's a PIM request where it's like dual control, where if someone wants to make a change, they have to request from the cab or the group. Is there an equivalent in AWS?
I'm not aware. So the question is there a mandatory two-factor authentication when you log into the AWS that you can configure?
Or if I want to, push configs, just code configs, I have to be approved by the group.
Okay. So the question is, when he wants to push a config to the AWS account, there's a secondary PIN you've got to insert to do that. I'm not aware of any control to do that as of right now. Yeah, I'm not aware of any. So is there any?
Just on the topic of getting that crafted request
Yeah.
to the phishing, that's where I think a control would have to be placed, because it seems very insecure if someone could just go in and accept.
Yeah, that's the way it's set up today, right, by default in the AWS accounts. So the question was, there should probably be an additional control implemented before you deploy the stack, right? So, and I agree with that. But yeah, as of today, I'm not aware of any way to configure that. You could have your environment set up, so you have a really stringent CI/CD pipeline, right? And stacks are only deployed by going through that set CI/CD pipeline. I mean, we've seen that with clients pretty regularly, right? So especially clients that highly rely on infrastructure as code type models, where they're not letting engineers kind of go in and spin up resources unless it's going through kind of a standardized process. Okay, yeah, if you got questions, just come to the front. Happy to talk to you. Thank you for coming out. Appreciate it. I got some stickers for B-sides. All right, thanks. Have a good day.